So let's break it apart, shall we? Terrestrial. Terrestrial? What does terrestrial mean?
That's extraterrestrial.
Yeah, that's extraterrestrial, right? So ET, right? He's extraterrestrial because extra means outside, right? So terrestrial actually means ground-based or earth-based. Okay. So the picture looks something like this. Here's the curvature of the Earth. Okay. And what you can have is all of these towers set up that don't use radio, right? Radio is multi-directional; it just goes everywhere. Okay. Hence this kind of diagram. Just it has no direction. Okay. But microwaves are in a certain direction to try and get to someone who's far away. Sending a signal like this. Okay? So microwaves refers to the fact that it's a very high-powered kind of signal. Okay? Because microwaves, the smaller the frequency, or the higher the frequency, the smaller the wavelength and the higher the frequency, the more energy that goes into this. Okay? So these signals can travel tens of kilometers at a time. Okay? But because they're directional, again, just like with infrared, you require line of sight. Okay? And so you're going to have actually several of these set up. And they have to be able to see each other. Okay? They kind of look like Christmas trees. But anyway, you get the idea. Right? So, these can go much, much larger distances, terrestrial microwaves. Okay? Lastly, we are going to go extraterrestrial. Yeah, question?
Just with terrestrial, what's the cause of interference?
Yeah, good. So the question of interference is always an important one because it's going to muck around with the signals. The answer is anything. Anything that gets in the way. Anything that, sources of radiation that are in between here. Okay, and so you got two things. Number one, that's why these signals are so high-powered, because if you can imagine this, compare a high-power signal to like someone who's shouting really, really loud. Okay? Now if I'm shouting really, really loud at you, you would have to introduce some very, very loud interference to get over my signal. Does that make sense? Okay? So the higher power this signal is, the higher power the interference also has to be to actually change what's being received. Secondly, terrestrial microwaves, we associate, if I'm talking to you, I'm having a conversation with you, I say something once, and you're like, okay, sure. But if you don't get it, you're like, oh, wait, what did you say? And so you ask for clarification. But under this system, things are frequently sent just multiple times. Okay? A signal might be sent 10 times. Okay? And when you look at it, you're like, 5 of them are different, but 5 of them are the same. And that's how you know that's the one that you actually want. Okay? So these are just ways of avoiding errors or trying to make sure that you actually get the right signal arriving. Okay? So interference happens all the time. That's the big thing with wireless, actually, that anything can creep in and muck around with the signal.
So there's less chance of interference with that, or?
Less chance compared to what?
Compared to lower powers.
That's right. That's right. Which is why, though, in reality, for instance, I said infrared, line of sight, less than 10 meters, okay? In reality, it's much, much, much less than 10 meters because there's all kinds of other infrared things that can get in the way, like, my hand, or your body, or anything like that, right? So, yeah, the lower powered it is, the less far it's going to go.